All right, so who remembers how to tell if an equation is a function or not? If you don't mind showing yourself too, that would be great. No one remembers? That's cool. All right, so remember there's a test that we use to figure out whether an equation is a function called the vertical line test. And it says that for any y value or any x value, there's exactly one y value to go along with it. So that's one way to figure out if an equation is a function or not. You can graph it and see if it passes the vertical line test. Another way is to just look at the problem. So for any x value that we pick for this one, we're going to get a unique y value, right? Like if we pick 1 for, let's do better. If we pick 2, we're going to get -2 as our y value. If we pick -2, we're going to get -4 as our y value. So no matter what x value we pick in here, we're going to get a different y value. So this one is a function. Well, that was weird. It signed me out and brought me in as a different person, so I'm on here twice. Oh well. All right. So the best way to figure out if an equation is a function or not is if it's in the form of y equal to mx plus b. So the equation of a line. If we look at this one and try to get it in terms of y equal to mx plus b, we would first have to get y to one side by itself by adding 1. Yeah. Hold on a sec. Can you see it now? All right. Sorry about that. if we solve for y for this one, we have to take the square root of both sides, right? Who remembers what square root functions look like from Algebra 2? From my class. It looks something like this, right? For this one, we have a positive square root function and a negative square root function. So does this one pass the vertical line test? No, it doesn't, because if we draw a vertical line anywhere on this graph, it's going to touch our graph in two different spots. So this one is not a function. Anytime you have some weird thing going on with the y, more times than not, it's not going to be considered a function. Like in this one, we had y squared. Any questions on that? Kristen, you look stressed out already. All right, the next thing is evaluating functions. Who remembers what f of 3 means? What does that tell us to do? Yeah, substitute 3 for x. So if f of x is equal to 2x squared minus 3x, then f of 3 is going to be 2. Instead of x, we're going to put 3. And then you just solve. So what do you get? What did you say? 9. I think so. So order of operations says we have to do exponent before multiplying. So we get 18 minus 9, which is 9. B is asking us to take f of x and add it to f of 3. F of x is 2x squared minus 3x, and we just found out that f of 3 is 9. So that's it. So this portion was f of x, and this portion was f of 3. Simple enough. What do you think you have to do for C? Any guesses? Huh? Yeah, you multiply that by what? So it tells you to take f of x and multiply it by 3. So that just means we're multiplying 2x squared minus 3x by 3. And to do that, we have to distribute. So we get 6x squared minus 9x. All right, what about D? So what do we do with whatever is inside those parentheses? Yeah, we substitute it for x. So we would have negative x squared instead of just x. And then minus 3 and then negative x. What is negative x squared? Right, it becomes positive x squared. When you square a negative, it becomes positive. What about negative 3 times negative x? Becomes positive 3x. Do you need me to go over E and F, or you think you got it? All right. She says her. So this one is just like C, except instead of 3, we have a negative 1 in front. And F is similar to A. Except instead of just 3, we have 3x. But we still do the same thing and put it in place of x. Let me know if I'm going too fast. What do we get here? (18x squared). Yes, because we have to square the 3x first, and that becomes 9x squared times 2 is 18. And negative 3 times 3 is negative 9. Any questions on those before we move on to the last two? Remember how to do these? Kinda. What'd you say? Yeah. of this one. Because when you square x, it just stays x squared. Remember, you have to square both of those. So when we squared the 3, it became 9. And then we multiplied it to the 2 to get 18. Yeah, I just skipped steps, sorry. Kevin, what did you say? If it asks you to simplify, yes, but for right now, no, it doesn't matter. But yeah, you could. All right. How about G? G looks a little different. What is f of x plus 3? So what do we do with whatever's inside the parentheses? It said multiply it. What did we do with this 3? Yes, we substituted it for x. So what do you think we have to do with x plus 3? Substitute it for x. Doesn't matter what's inside this parentheses. You have to substitute it for x. This one, to simplify, is a little more work than the other ones have been. What is x plus 3 squared? X squared plus 9? Ryan is getting it. So remember from my class, yes, Michael is right. Whenever we have a quantity squared, we have to write it twice. And then distribute or FOIL. So when you distribute and FOIL, you get x squared plus 3x plus 3x plus 9, which combines to x squared plus 6x plus 9. Any questions on that part? Are we good? Now we can just distribute the 2. After we distribute the 2 and there's nothing else around the parentheses, we can just drop it. And then we can start combining it with stuff on the outside. Any like terms to combine? So we have 12x and negative 3x. What is that? Remember, we cannot distribute exponents if there's a plus or minus sign on the inside. We can only do that when everything is being multiplied, like this one. We were able to distribute the square to the 3 and the x because they were being multiplied on the inside. And that's how we got the 9x squared. But for this one, we couldn't do that because of the plus sign. We had to write it twice and then distribute. All right, this last one is very important. You're going to see that when we get into limits and derivatives, but for now, we're just going to stick with Algebra 2 stuff and plug it in like it's asking. So I'm going to need some more room. We have f of x is equal to 2x squared minus 3x. That's the given. And we want to find what f of x plus h minus f of x divided by h. So we can break this into two parts. The second part we actually already know because that's what they gave us, but this part is what we need to find. What is f of x plus h? What do we do with the x plus h? Substitute it for x. Check you out. What do we do with the x plus h squared? We write it twice and then multiply. I'm not going too fast, am I? Are you good? All right. So we do x times x times h times x, and then h times h. So that's just from this first part. Huh? We following? Did I lose anyone? So one thing I didn't mention last time, calculus is at our pace. So if I need to slow down or if you feel like I'm going too slow, we can speed it up. Just let me know. Like, we're not in a rush to get anything done. we are not, like in Algebra 2, we have to hurry up so you can take the SOL. There is no SOL or anything for calculus, so it's at our pace. When we distribute the 2, we get 2x squared plus 4xh plus 2h squared minus 3x minus 3h. Do we have any like terms we can combine? No, we don't. So this is what f of x plus h is. Now let's go back to our problem. Yeah. What is negative f of x? Any questions on how we got that? So f of x we were given to be 2x squared minus 3x. So negative f of x just means we make the signs opposite. And all this is divided by h. Are there any like terms we can cancel out? We have the 2x squares and we have the 3x. Those. Yeah. So it's like 2 minus 2 and 3 minus 3. So that, yeah, right. And then we're left with 4xh plus 2h squared minus 3h, all divided by h. Can we simplify this? Not exactly. Huh? Yeah, we can cross out some h's. So, since there's only one term in the denominator, we can simplify. So there's one h up here that would cancel up with this, with one of these h's. Actually, it'll be better if we write it out like this. That's supposed to be an h. It's supposed to be an h. Huh? Yeah, this is the review. Where did I lose you? Don't lose faith. But where did I lose you? All right. Okay. We're good with this part, right? So far. Okay. I don't think those matter so much, but if we need to come back to it, I will. I'll see. I'll let you know. So because we only have one term in a denominator here, we can split it up in terms. So this term is being divided by h. This is also being divided by h. This is also being divided by h. That's why we can split it up like this. And then if we simplify, the h's cancel out here. We have two h's here and one h down here. So this one goes away and one of these goes away. We have one h up here, one h down here. They cancel each other out. We'll be doing more examples of these. Do you want some now to work on? I'll give it to you as homework. All right. I asked if you wanted to do some more examples of these, because you will be doing it once we get to limits. You said, am I going to do it? Of course I will. I'm going to let you try it first, and then we'll come back together. I'm making this part up, but everything else, the notes that we were going off of earlier, that's on Canvas. And I'm also recording this, so if you need to go back. All right, we have f of x is equal to x squared minus 3. I want you to find f of x plus h minus f of x divided by h. The class recordings will be under class notes. I can show you again before we leave today. Just remind me at the end of class. I'm not recording you guys. I'm just recording the pad over here. Jimmy. All right, so if it helps to break it up like we did up here and then bring everything together, I do recommend doing that. I'm going to take a guess and say the answer is 2x plus h. I'm just guessing. I didn't do it either. Anyone get the f of x plus h part? Did you get the f of x plus h part? So like we did it up here. Cool. I'm writing it up, so if you're not ready, don't look at the screen. Abigail, can you mute your mic? Thank you. Sorry, I figured I'd save you then. Everyone get that for f of x plus h? For this one, the only place we had to put x plus h was in here because that's the only place we have x. In the first example, we had x in 2 different locations. That's why we had to do it twice. Yeah. Oh. So up here for the first example, x shows up in 2 different locations. So we had to plug in x plus h in both locations. But for this one, x only shows up once. So we only had one place to plug it in. Good? And what is negative f of x for this problem? Yeah. Can we cancel anything out? We have negative 3 and 3. Anything else? and we're left with 2xh plus h squared divided by h. If we split it up like we did up here, we'll see that one of these h's go away, and then one of the two from here goes away. We good? The next thing we're going to talk about is domain of a function, but I think this is a good start for today. So I'm going to just give you some practice problems on this to do, and that could be your asynchronous part for today. Sound good? Alright, this will be your homework, and I will post this in under assignments on our Canvas page, so you'll have the problems up there and you can submit your answers on there too.